This is a video to give you a little bit more background about the Excel graphing exercise that you have to do for Lab 1. And this will be the basis for all of your other labs because you will be producing graphs using Excel with the data for the other labs. So a little bit of background. When you have a graph, y versus x, and you do an experiment and you get your data and you graph your data, if you just graph the data points as points, and then you do a best fit line, the slope is what we're interested in. So we're always going to manipulate your values such that you get a straight line for the one thing, and then also that you are interested in the slope. Now, what we want to know is just how much uncertainty there is in this slope. Doing the correlation coefficient is not what we're after. We're after uncertainty. So there is a function in Excel called lineest. I think it stands for line estimation. And the code that they use in this function, I cannot find anywhere. However, what they are measuring is just how far away from the line the data points are. In other words, the uncertainty that the lineest function gives you is a measure of just how scattered the points are. So for example, if that were the slope, it could still be the slope if my data points were like this, right? As long as the data points are scattered sort of equidistant. Now that would be a totally different experiment and obviously way more uncertainty if I'm doing a best fit line with these points miles away from that line. So lineest does give you that kind of uncertainty. However, most of the time, that's not the situation. Most of the time, we're going to be dealing with uncertainty in the data such that we have error bars. That's what error bars are for. So when we plot our data, it will be some value of x, some value of y, plus or minus. And that's what the error bar is. Now I'm not going to deal with plus and minus in the x direction. It just gets too complicated. So we'll have a plus and minus, and you can get Excel to graph these error bars. It does a fine job of that. So let's say we have data with these error bars, plus or minus, that look like that. Now we want to do a best fit line. Well, the actual data points, which are these, the best fit line is the same no matter what you do. It will simply do a best fit line in those circles. However, the uncertainty now in the slope, now in the old days we used to do this by hand, and what we would do is we'd sort of estimate, now if I use these bottom data points and the top, that might be the maximum slope going through those error bars. This is the experimental data because that's just the points. And then we have a minimum slope where I'd use sort of the top of the error bars and I kind of go, kind of like maybe this. Making sure that line goes through the error bars and takes into consideration the plus and minus on the error bars. So that would be the min slope. The uncertainty in slope by definition in slope is equal to the difference between the max and the min, max slope minus min slope divided by 2. So it's just half the difference between those two slopes. Now, unfortunately, I can't find any code anywhere that will do this for you in Excel. And so what I've done is just made up sort of my own algorithm here. So what I've asked you to do is, in order to get these max and min slopes, take the bottom point of the error bar of the first 3 data points, miss the middle one, and then let's say we have some more points up here. I think we've got 7. And then take the top, miss the middle one, and then take the top 3 error bars for the last 3 data points up there, and then tell Excel to do a best fit line through those. So let's see if I can change color here. Red. So now it's say to Excel, do a best fit line through these boxes, which are the top and the bottom of the error bar, and that's your max slope. And then similarly for the min slope, you take the top of the error bars, miss the middle, and then the bottom of the error bars, and tell Excel to do a best fit line, that for your minimum slope. Okay, so that's how you're going to get the uncertainty and slope using error bars. And that's what those instructions tell you exactly what to do. Now, the slope that we're trying to compare to, most of the time it's going to be some physical quantity that has to do with physics. In this case, it's simply, we're working with, go back to black here. Black. We're working this equation that the period of a pendulum, I need to go a bit thicker here. The period of a pendulum is equal to 2 pi root L over G. So T is period, L is the length of the pendulum. So those are the two variables that would have been measured had you actually done this experiment. Now, if you graph T versus L, you're not going to get a straight line because you've got the square root. So in order to get a straight line, we have to square this equation. T squared would be equal 4 pi squared L over G. Now, to get a straight line, y equals the slope times x. It means on the y-axis, we have to put t squared. On the x-axis, we have to put pi squared L over G. The slope would then be 4. And so that is the graph that you're doing. And this t squared is what goes on the y-axis. That would be in seconds squared. And then pi squared L over G goes on the x-axis. And then you would get a straight line, the slope of which should be 4. And that's your theoretical slope. So that's what you're trying to compare to. So if you're not getting a slope close to 4, you've definitely goofed something. Okay, so that hopefully sort of explains what you're doing. If you have more questions, just email me and we'll see if we can deal with the questions.